Intermolecular forces. Intermolecular forces. Covalent bonds are intramolecular forces. The properties of a substance also depend on intermolecular forces, also known as IMFs. IMFs exist between neighboring molecules as opposed to intramolecular forces, which exist inside molecules. As it shows in the picture here, intramolecular is attractive forces in a molecule, otherwise known as bonds. Intermolecular are attractive forces that exist between different molecules. They're not a physical connection, but actually result from the existence of positive and negative charges in the two molecules. Intermolecular forces are much weaker than intramolecular forces due to the greater distance between charges, which diminishes the Coulombic attractions. There are essentially two types of IMFs, or intermolecular forces: London dispersion forces and dipole-dipole forces. London dispersion forces occur between all molecules and are caused by the temporary polarization of molecules due to the random positions of electrons. Since electrons all travel so fast, what happens is that occasionally all of the electrons, or more of the electrons, will be on one side of the molecule than the other. Therefore, when that occurs, it creates what are called temporary poles, where the side that most of the electrons are on will be negative and the other side will be positive. These polarized molecules then form attractions called London dispersion forces, where the temporary negative poles of one molecule are attracted to the temporary positive poles of another molecule. The greater the number of electrons in the molecule, the greater the polarization and the stronger the London dispersion forces will be. Take iodine. An iodine molecule has 106 electrons. Therefore, it has a melting point of over 113 degrees. Iodine, as we know, is a solid at room temperature. Fluorine, on the other hand, only has 18 electrons. Its melting point is a very low minus 219.7 degrees Celsius, and it's a gas at room temperature. The surface area of the molecule also influences the ability of LDFs to form. The greater the surface area, the greater the London dispersion forces, all else being equal. In this course, we will concentrate on the number of electrons. Now, the ability of an atom or molecule to become polarized is called polarizability, and we may refer to that in the future. Know that that means how much a molecule can have its poles or its electrons shifted to one side or the other.